Welcome everyone. Again, my name is Diaz. I'm a part of a team at Microsoft called the Global Black Belt Team, which is a team of technical sales engineers that have very good tied in with the product team. So our team is directly sponsored by the engineering team. And with me, I also have Valerie High, who's my manager. So she runs the team of specialists on for the Americas. So that's who we are. And our goal here is to give you just kind of walk you through the journey that we have taken, several customers through to realize the promise of IoT. And through that, it has been some very good lessons learned around how to get the companies to really change their mindset and to adopt this new way of thinking. So hopefully, by the end of the hour here, you'll walk away with some very good samples, real life samples of some of the scenarios that we were able to implement, some of the roadblocks, how to overcome them. We'll talk in depth about two particular use cases that we worked with, customers that I directly was involved in with Hershey and Bears Pharmaceuticals. And then at the end, also, we'll give you some in-depth demos around AI. Because at the end of the day, the reason that we do IoT is so that we can get some sort of insights on our business. So I like to talk about it as IoT is just the gateway to AI. Make sense? So we are in the middle right now of a pretty big revolution. It's a pretty big disruption in the business. It's kind of the same way that steam and electricity was back in the century ago. The digital revolution is here, and it's poised to make a pretty big impact in the way that we do business and in the way that we actually even live our lives. If you think about it, digital is really everywhere. If you survey, some researchers have surveyed a lot of IT departments in the world, and they're finding that over 50% of them are now implementing API strategies for the company. I mean, think about that for a second. If you've been involved in IT or in technology for more than 10 years, IT are not the easiest bunch of people to work with, right? Pretty close-minded for good reasons, right? Their job is to protect the infrastructure. If something goes down, they get blamed. They never get any accolades for doing anything. So they really guard their IP really tight. But now they're exposing that data via APIs. Right now they're trying to find ways to innovate their business. They're trying to turn themselves from a call center to a profit center. Right? If you see, if you look around, just what we see in devices, right? The estimate is by 2020 we will have 1 million devices per hour being introduced into the market. Think about that for a second, right? Because now everything can be a device, and we'll talk a little bit about. In fact, John from Machine Q, Comcast Machine Q, is talking today. Go to that talk. Great technology around LoRa. Anything can now be an IoT device, right? A pill bottle could be an IoT device. Think about that for a second. Right? So that's where that 1 million per hour number comes from, right? Now, what about the companies that we have today? Right? The average age for a company in the S&P 500 is 12 years. That means that the old businesses are just dying. They're going away. Right? So if you don't rethink the way that you're doing business, if you don't adapt, if you're not willing to change your mindset and just roll with the punches, chances are that you're not going to be around in a couple of years. That's just statistics, right? I mean, look at Uber, right? Who would have thought that taxi companies could be revolutionized? Or even Airbnb, right? All these companies have been born in the digital age, right? That's the big disruption. But why is this happening, right? Well, there have been a lot of different technologies that have democratized the market, right? If we look at even drones, for instance, about a percentage of what they used to cost 10 years ago. Right? I have one now that my wife got me for Christmas, and it's the best thing ever, right? Robots, artificial intelligence now is for everyone, right? Everyone now is a data science, which could be good and bad. Right? Solar is a lot cheaper. We have on a single integrated circuit now, today, more transistors that we had human beings 20 years ago, right? I think the average size, we can put it up to 7.6 billion transistors on a single chip, right? So that's why this is happening, because the technology is getting better, it's getting cheaper, right? If you look at the amount of compute power that we have today, it's just years ahead of where we were 10, 20 years ago, right? Moore's law is still applicable today. So technology is getting better, technology is getting cheaper. Users, right? So our end users are getting smarter. They're born in the digital age, right? So now all this is coming together to create some pretty good destruction. It's not the first time we've seen this, right? We've seen this before. The internet was a big one. Oops. The internet was a big one. Mobile, right? Open source. For us, that was a huge one for Microsoft, right? Right. But we had to adapt and we had to embrace it. So you have to roll with punches. The sharing economy, that's another big disruption. Cloud computing, another one. So the key here is that if you talk to some of the customers that we talk to, right, they're still not even in mobile yet. So how do you bring them to digital? Right, they haven't fully implemented cloud computing. They still think that that's evil. Right, we go to some shops and we talk to people, and they're afraid of cloud computing, right? Mainly because they see it as a job risk, is what I'm finding. But still, right? So it's a hard thing to get people to adapt, right? But the only thing harder than transforming your company is failing to transform, right? If you think about the opportunity, both in business and even just consumer, right? It's about a $100 trillion business in the next couple of years. And the threat is that if you look at the list of companies that are in the S&P 500, the average age is pretty low, right? So companies are dying. So we have to do this. So here comes IoT to kind of save the day. At least I think it's here to save the day, right? IoT is really not a technology revolution if you think about it. Although there's been a lot of technological advancements that have made this thing possible, right? So again, transistors are super cheap, super small. Communication between device and cloud is getting better. It's getting cheaper. It's getting more battery effective. Right? So there's technology affecting it, but it's really about a business revolution, power by technology. And I look at it as a gateway to digital transformation, because it is one small siloed thing that you can do within your company that can get your employees, your team thinking about how to change their mindset. So let's define IoT real quickly so that we can get in the same page here. If you talk to different vendors, if you talk to us, if you talk to Google, Amazon, they'll probably have a very similar definition of IoT. But if you start talking to some of the niche players, PTC maybe, or ALA, those guys, C3 IoT, they might have a different view. Right? If you talk to even more of a niche player than that, they will even have a narrow view. Well, for us, IoT is all about things and how we connect them. Again, because there's multiple technologies, there's multiple requirements. I was talking to a customer yesterday that needs to have a 3-year battery life on his device. Right? That's pretty hard to get on a cell chip, with a cell radio. It's almost impossible to get. So there needs to be a way that we can make that connection happen in a cost-effective way. Right? So it's not only the thing, but it's also how we connect to it. How do we ingest data? And then here's really where the magic happens. Right? This is what we do IoT for the analytics, and so that we can take actions. Right? So that we can know if our device is going to fail or not, so that we can preemptively go in and fix it. Right? So quick little scenario here. Rolls-Royce. Right? The car company also happens to make engines for airplanes. They completely changed the way that they do business now, where before they were charging you for an engine. Now they're charging you by the hour, because they're able to provide so much analytics on the way that the engines are running, that they're able to predict how often they're going to fail, when they need to be serviced. So instead of saying, hey, here's the engine, good luck, see you in a couple of years, now they can say, no, let us do that for you. We'll manage the service plan. We'll take care of that, because we believe that we can do a better job because we have all the data. But it's completely transforming the way that they do business. That's actually one thing that we're seeing too with customers. They're turning from customers to now partners, because now they're able to sell what they're doing to their own customers, to new customers. They're finding new revenue streams. We'll talk about that in a second. Right, so this, again, is really why we do it, for the analytics and for the actions. So what happens when you embrace it, right? When you embrace this transformational technology within IoT, what happens is you start receiving new revenue stream. One of our customer does collects data on animals, and I'm going to get to the specific on that one because that one's not public. But they collect information on animals, so they're able to detect when the animal is going to get sick. They're able to detect if they know that the animal is sick. They know how much they're eating, and based on all that information that they have about the animals, they have a lot of information about the industry. So now they know how much food the industry should provide to the to farmers, right, who's raising these animals. So now they're taking that data, removing any animal information, they're summarizing it, and selling it as a separate business, right? Because it turns out that pet food companies really want to know how much food they should manufacture for a particular season. So completely different. That was not even on their path. They were not even thinking about that. But all the data being collected, they saw these patterns. They started selling the data. So now they're becoming data providers as well. Right, so new revenue streams happen often. New way to engage your customers. Right? Imagine Otis. No, Otis. It's the other elevator company. Crop. I can't. What is it? Anyway, a big elevator company. They embraced IoT. They're using our technologies, and by they collecting the data and analyzing the data, they're able to determine when the elevators are going to fail. So they're able to send technicians before it actually fails. They're able to reroute technicians that are in a particular area and say, hey, go to this building over here, service this elevator because we think it's about to fail. So instead of waiting for 3 months, doing it frequently enough, right, to even prevent it ahead of time. So imagine a particular elevator takes 3 months to fail, right? It's pretty bad when an elevator fails, right? So as a company, what would you do? You probably start servicing every 2 months. Because you want to make sure that it doesn't happen. But now if you have the right data and you can predict when it's going to fail, you'll probably move that window and leave it at 3 months, right? Because maybe it might take 4 months to fail. So you're able to write that alone because you have the data and you know exactly when that particular equipment is going to have some issues. So the point is that you send the technicians right at just the right amount of time to get it fixed, saving operational costs. Making your customers happy, right? Being able to engage them in a different way. Not only that, but in this particular case, they were also able to now service other elevators that they didn't manufacture because they also had the data. Right? So now they moved from just servicing their own equipment. Now they can service other equipment as well. Right? Again, product transformation. We'll talk about the case of Bear in a second, how they were able to transform on their products using IoT and optimize their operations. So those are things that we typically see when companies do that. So I'm going to give you 2 examples, use cases. If you have any questions, feel free to ask on those use cases. And then from there, we'll give you just a quick little demo of how Microsoft is doing that in some of the technologies that enables these projects. So the first one is Hershey. So Hershey's one that we've used a lot. We got a lot of press because you will not imagine that they were actually having this problem. So Twizzlers, right? Everybody loves Twizzlers. They were having, some people enjoy Twizzlers, I guess. They were having an issue with not being able to predict the amount of candy that they were stuffing on a 1-pound bag. Sometimes it was a pound, sometimes it was less than a pound, sometimes it was over a pound. They couldn't determine exactly the amount of candy that they were being stored. Now, you imagine Hershey, big, multi-billion-dollar company. There are very sophisticated manufacturing systems. They're collecting tons of data, yet they really didn't have any insights on the data. It's traditional manufacturing operation systems. Uh, we collect a lot of data. We don't really have access to that data. It's kind of the pattern that we see a lot. Right? So they captured tons of information, yet they were having this problem. So how did we fix it? Right. So it was a partner of ours, New Signature, a local partner, in combination with us. By adding a few different sensors outside of their manufacturing operations, they were able to determine the variance in temperature of the batch. And by running it through some machine models, they were able to determine that the variation in temperature and where that variation happened in the manufacturing process was causing the mix to be either too thin or too thick, right? Which then allowed the extrusion to be less or more depending on what they were trying to produce. And so our solution ended up being connecting to their manufacturing systems real time. We did that via an MQTT channel, MQTT topic. We were collecting tons of data on their sensors. We would take that data and analyze it real time. So as the data came in, we analyzed it using a service that we have called Azure Stream Analytics. You could have used something else. You could have used something like Storm or Spark. The technology really doesn't matter here. It's just the what we were doing. So we were analyzing that real time. We were taking that value and getting a score from a machine learning algorithm. The same machine learning system that Valerie is going to talk about, right? So it's the same technology. Get a score. Should we slow down the extrusion or should we speed it up based on the temperature variations that we were seeing? And by doing that, Hershey's able to save per line, right? Not per plant, per line. I think it was $500,000 a year per line, just by being able to predict the exact amount of candy that they were extruding. So their gain is not your cost, because now you're getting less candy. Right? You're getting the pound, not a pound in a couple grams. But sometimes you might be, yeah, you were getting more. So in this case here, what's interesting about it is if you think of, again, very complex manufacturing operation. Right? These guys are not amateur by any means. Yet, they couldn't predict the temperature variation. Right? Because many times what we're finding is that these systems are very close manufacturing systems. So the idea here is to not change what they have, but add to what they have. Right? The manufacturing process has to be controlled. It has to be very much tied up. Can't have any loose ends. It needs to be the way it is, and those systems typically get implemented and last for years. They don't like to touch it. Once it's a closed system. But what if you can add to it? Right? What if you can enhance? What if you can grab some of that data and export it to your own system so that you can analyze it and do what you need to do? So that was Hershey. Again, the lessons learned here is don't assume that just because you guys have a sophisticated operation that you cannot get better, or that you cannot take advantage of what IoT can do for you, right? Even if you have all the equipment in the world, right, there might still be ways to improve it via IoT. So embrace it. Another project there that we worked on was with Bayer Pharmaceuticals. So Bayer Pharmaceuticals also has an environmental science division. And this is pretty cool because my partner got to speak at Pest World, right, which something that she never dreamed of. Well, she said that since she was a little girl, she dreamed of speaking at Pest World. But here's the problem with this industry, right? And it's funny because once you see it, now you cannot unsee it. So not only restaurants, but data centers, big warehouses, they have to put these rodent traps all over, right? You hardly see them because they're kind of tucked away on their. If you go to Home Depot, you'll see them if you kind of look in the corner. And they have to send technicians, like weekly, to go check the straps. The problem was that these straps don't often get anything, right? So they're just kind of sitting there. So imagine having to send a technician constantly, bending over, looking, is there something there? No, go to the next one, right? And check, hundreds of traps a day. That's a problem. So they came up with a way to have a trap, right? They actually they went through the. This is a great story of going through the iteration process, right? So they were innovating fast, innovating cheaply. So they were just buying sensors, playing around with things, and they came up with a LoRa-based technology. So they are using LoRa for this to be able to. Why LoRa? Because of the battery life. Right? They don't want to have to replace the battery life of these traps on a weekly basis. Now, they want to do it every few years. So the mouse comes in. There is a radio signal via LoRa that gets sent to a gateway. From there, it goes into the cloud, and now they can alert the operators. Yes, go check that trap now. There's a mouse in there. So um, for the company, for their customers, the pest control companies, they're able to now lower the cost because they don't have to have somebody there constantly um, checking the traps. But what else can they do now? Now they have tons of data they're collecting, right? So imagine if I just take basic environmental data, temperature, humidity, light, maybe even sound, some other things. Can I now detect, based on that information, how much rodent activity I might have in a given location? I can take that information and match it up with some weather information, right? Was it raining? Was it very humid outside? How much rain did we get? So now I have rodent activity, micro environmental variables, and I have macro environmental variables that I can collect together and try to make sense out of it. So that's how they're now able to revolutionize the way they're doing business by being able to provide this technology. And this is just the beginning for them. Right? They have all the products now that they're working on to do the same. Great folks to talk to. If you, they're more than happy to talk to you guys if you have similar scenarios, or if you want to see how they went through the process of going a huge big company to being able to innovate at this level. Typically, what it requires is a different division, right? Different team with uh, with a mandate to go innovate. So these guys operate almost as a startup within Bear, and they're able to create some pretty cool things. One note here, not for this project, for the next project, one of the things that Microsoft can help is that we have a lab. We have 3 locations for these labs. We have one in Redmond, Germany, and one in China somewhere, where we can bring customers in for a week, 2 weeks, sprint, and we can do multiple of those sprints and help you iterate through your product ideas. That team is staffed by electrical engineers, embedded engineers, mechanical engineers. We have a full fabrication lab, so we can produce prototypes for you, units that you can use as you iterate through your project. And what we're finding is that it's saving about 4 to 6 months worth of time for companies to go through that lab. And that's a pre-sales engagement that we do. Not only that, but you keep your IP. The folks that we have in those labs don't work for Microsoft; they're vendors. And we do that for a reason, so there's no IP issues or concerns. So some of the things that we've learned with these engagements. Oops, got to build this thing. It's not building correctly. That's unfortunate. But I would just use the. This is supposed to line up really nicely, but changing computers in the middle, kind of. But anyway, so a couple of things that we always say. The first one is think big, but start small. It's a big journey, right? And there's a lot of moving parts in IoT, and it sometimes could be overwhelming. Right? But you can start big with a big vision. You can think big, just start small. Pick a small project. I have a couple companies that their first IoT project was literally to put a couple Raspberry Pis with some sensors on conference rooms to detect light, to detect motion, to see if the conference rooms were occupied or not. No business value at all, other than for them to start thinking about the possibilities. That was the purpose, right? Let's see how this IoT stuff works. And now that company has 2 projects ongoing in the animal health division for themselves, doing some pretty cool things. The other one is be honest about both your intent. We get calls sometimes. This is probably me complaining a little rant. We get calls sometimes from a director of innovation of X company, And literally, all they want to do is to have a check mark that says, yeah, we talked to Microsoft about IoT. So now I can go, and it's like, oh, don't waste your time. Don't waste ours either. If you're going to be honest about your intent, then be honest, right? If you just want to know about the possibilities, fine. We're happy to have that conversation. But if you really have a project, right, we can really help you. Not just us, but there's a whole bunch of companies involved in this journey. So be honest about your intent. Be honest about your environment, right? Are you still stuck, in the pre-internet ages? Are you not able to really innovate that fast? Because if that's the case, then we might have to do some things before you get to IoT, right? There might be some things that we have to do internally before we get you there. Right? So be honest about your environment and your ability to even try to execute. And about your commitment, right? Are you really doing this for real? Like, do you see a project? Do you see a vision? Or is this, again, it's just another check mark that you want to do? If it's just a check mark, you're wasting your time. And you're going to badmouth IoT, say, oh, this is just a myth, or this is a trend, and not really receive the true value of it. Change the mindset. Don't do a pilot. Excuse me, don't do a POC. Do a pilot. POCs go to die. They never go anywhere. Right? You say, I'm going to do an IoT POC. It just sits there with a whole bunch of, a little board like this, with a whole bunch of wires in a room. It never goes anywhere. And again, you wasted a couple months, and you went and you told your boss that, yeah, IoT is a fad. Right? So nothing's going to come out of that. Right? Change the mindset and think, no, I'm going to do a POC. Right? Because a POC has not just I'm going to develop something, but I have some customers in mind. Right? Maybe some of my friendly customers. It could be employees. It could be some other customers that are your preferred customers that will be willing to try new things, right? And try it with them. Say, this is my pilot, right? I'm going to produce something, maybe a minimum viable product. I'm going to build it. It might have wires hanging out. I don't care, but I'm going to show it to a customer, and they're going to try it out for a couple months. Right? So have that mindset. And what we're finding is if you have that mindset, then you're committed to it, right? Because you're showing something to a customer. Right? You're already having those conversations to see. And then the last one is, two more. Ideate, right? Get your people in the room. Thinker. There's a whole bunch of kits that you can buy. I have a little board here that it's like a $40 board, has a couple sensors. Play around with it. Feel fast, feel cheap. Right? $40 for a board, a couple $100 for a cloud solution, hopefully with us. But there's other vendors that do the same, not as good as ours, but they do it too. And you just try something out, right? And if it doesn't work, then try something else out. Right? You don't need to go ask. I have another company today that spent about 3 years in an IoT journey. And what they have today, it works, but it was way over what they really needed. Right? They could have just started a lot smaller, gotten the same value, iterate through the process. Right? That's where that agile mentality comes to mind. But again, a lot of companies are still not doing agile. Right? So you got to help them through these processes. And the last one is to understand that this is a journey. It's going to take time, and you might fail. Not only that you might fail, you might find out that for you to be really successful, you're going to have to keep innovating inside of your organization. Right? That you might have to change the way that you engage with your customers. That you might have to change your business model, and that could be scary, right? But you have to do it. Microsoft has done it, has completely transformed the way that we do business. It's a complete. I've been with the company 11 years in May, and it's a completely different company. And it can be scary when you're saying, if you saw the announcements, big org, Windows is now under Azure, right? So it's like Windows is cash cow for us, right? And now it's under Azure, right? It's under the cloud. It's almost like a implementation detail of the cloud now, right? But you have to change, right? You have to change. All right, so how do we help customers do that? What is our approach? Right, so the approach that we have to take, and this is just the one sales slice that I have, and then I'll do a demo. We have a series of services to help you through that journey, whether it is platform as a service, right? Where in cloud computing, that's where you get Lego blocks and you get to build your own house, or you get to build a mansion, and you can build the house however you want to, right? We give you full control over how you build your house. We give you services like IoT Hub, which is our cloud gateway. That is the guy that allows you to connect your devices to the cloud. That's what allows you to do bidirectional communication, allows you to do per device security, and a whole bunch of stuff there. We have a device provisioning service, stream analytics, time series insights, machine learning. So you basically pick all these components to build a comprehensive solution. We also give you a set of a starting open source solution that you can take the code, modify it, and kind of get started with your IoT solution. Right? And it's completely free open source. They are available. The remote monitoring one is in preview with a Docker-based implementation using Java or .NET. So we give you that choice. The front end is all React.js, so very open source, very much removing the Microsoft lock-in there. Right? So very, very good architect solution. And then the other layer is the SaaS solution. Right? We're not giving you building blocks. We're giving you the house. You cannot add a room to a house. It's a house. You can paint it. You can add furniture, but you can really do much customization. That's already built for you. That's software as a service. But you can still build some pretty nice solutions with that. And that's what I'm going to demo next. So for us, I have this little sensor board here. This is an MX chip dev board, about $40. Has a handful of sensors, has temperature, humidity, pressure, accelerometer, micrometer. Great for you to do a lot of different IoT scenarios, believe it or not, right? If you're trying to monitor equipment, you can detect vibration with this board. You can detect temperature and start getting some values from it. So what I'm going to go to our IoT Central system. And again, this is a SaaS solution that allows me to build. That's just for your benefit, yeah. She's a Patriots fan. So there you go. Don't rub it too much. My review's coming up. So here I have some devices. And again, I have this device here that I've been running for a couple of minutes now. You can see that I can plot data. I didn't have to write any code for what you see here on the screen. The only code that was written was on the device side to be able to connect to IoT Central and send data. Right? That was the only code that was written. Everything else here is just configuration. So I see measurements coming in. I can see, I can interact here with this, right? So I can turn things off. Excuse me, turn that one off. Maybe I don't want to see these things. Just want to see those three. I can change the averages and say I want to get a count instead, or maybe I want to get the minimum. Right? So you can start seeing some telemetry. You can start seeing some data. But you also have settings. So for instance, I can come here and say maybe I want the fan speed to be 2% or 2 RPMs, or maybe I want to turn on my LED or my IR here, right? So I can send commands back to my board, so I can take an action on the board, right? So Crestron is one of our customers too, a big home automation, conference room automation company, and they're using our solutions to be able to take command and control of the equipment on the field. So that's not just turning on an LED; it's literally managing hundreds of thousands of equipment in the field. So we have that properties, and this is what you will use to kind of mesh up your data. So serial number, manufacturer, time of deployment to a particular building, location, which actually I have to change this because this is not Seattle. Okay, so I can go, all right, save it. So now that metadata is being kept. I have rules, so I can say things like, if this condition is met, right? So if the temperature is greater than 60, I want to go ahead and send an email. Or this is still in preview. Once it's out of preview, hopefully sometime in the summer, I will be able to do other things instead of email. I can call a webhook, and once I call a webhook, I have pretty much access to anything. But I can send a text message. I can call a CRM system. There's a lot of things that I can do there as an action, right? Go call somebody, tell them to go take a look at this fan. It's about to fail, that type of stuff. And then lastly, I have dashboard capabilities, right? So I can showcase things like the maximum temperature, the average pressure, right? I can have some charts here. I can very easily change this, right? So if I come here into design mode, I can go in and say, you know what, I want to add another item here. So let me just kind of move this thing around. I'm going to go ahead and add another item here. I also want to show my magnetometer, right? So click on that, show it, click save, and now my bar has another value. Right, so very easy for me to very quickly build a solution. You can go from idea to a demo in no time, because we also include with this a simulator. So if I wanted to go in and create a new device model, just going to call this demo. Right, I can go in and I can start adding my own measurements. And so I'm going to call this, this is bending. Maybe I have a bending machine, so I want to know how many times I've bended an item. The field name that I'm going to pass is going to call bend. The unit is going to be items per day. The minimum is 0. The max is going to be 100. And notice that I now have this data being simulated right away, right? So now I can ideate through different scenarios and show something and play around. So I'll stop there and just make another comment that our commitment to IoT is pretty big. In fact, just perfect for this conference, because just yesterday we announced a $5 billion commitment to IoT over the next 4 years. So that's $1.25 billion, which remind me for my race conversation. That's going to come in handy. Into IoT, right? So that's our commitment to it, which is a pretty big commitment from a monetary point of view, so that we can keep enabling these systems to allow you to disrupt the way that you're doing business today. So I'll have Valerie come up. We're going to switch machines real quick, or? No? Okay. So here's the... And then with the, if you guys were here, I'm actually local to Philadelphia, so if you have ideas, if there's something that we can help you with, I'll be more than happy to walk you through that journey. Thank you.
Can you hear me? Work? Okay, great. So probably everyone has come into the room today with some preconceived notion as to what artificial intelligence means to you. Maybe some of it is based on the decade that you grew up in and the TV shows and movies that you were watching at the time. According to one of the entries on Wikipedia, artificial intelligence is intelligence exhibited by machines mimicking functions associated with human minds. So that's the Wikipedia definition. To me, I think of artificial intelligence as programming a computer to act like a person. So simple. I say programming, of course there's a lot that goes into that programming to get that action. In general, it's understood that artificial intelligence will have 3 different characteristics. The first is some sort of ability to reason. So you take large amounts of data, you apply machine learning algorithms to it, and from that, you're going to have different decisions that are made. Now, once you do that, that doesn't mean the learning is over. You're going to continue to feed in new data after you've learned something the first time around, refine the models, and then hopefully your intelligent agent will be even better at making decisions. So the second quality is some sort of an understanding. And the way I think about this is you're not just looking at data like temperature or vibration, things that we can all, a computer could easily understand just what the numbers mean, but it's taking items and giving it meaning. So if you were to have a picture, to be able to extract out that this is an apple and this is a black car, something like that. That's more information that can then be added into your machine learning system. And then finally, we have the interacting, or the acting like a human, like a person. So you have to lower the barrier between the humans and the machine so that it feels like it's a real natural interaction that's taking place. Now, given that we've all been hearing about AI for years, why now? Why does it seem like in the last 5 years, everybody is talking about artificial intelligence? I think a lot of that comes from the advancements in the algorithms. There are more sophisticated algorithms than there were years ago. We're beyond linear regression. We're doing things like deep learning. That's another new thing that people have been talking about in the last few years. It's interesting. Deep learning, I looked it up a few years ago because I didn't know what it was, and I hadn't heard of it in grad school, which wasn't all that long ago, at least I like to think. And it turns out that deep learning has been around since the 60s. And some variations could be deep neural nets. So basically, if you have your input layer of a neural net, your output, and then you have all these layers in between, it used to be just 1 to 2 layers. Now you can have 50 layers, 80 layers, and really mimicking some sort of a process. So why did I not know about this 10 years ago when I was doing neural nets? Well, that's because the compute power is so much bigger than it was a decade ago. So having the cloud is removing the barrier to the large-scale computation that I couldn't have just done on my laptop, or maybe enterprises weren't as easily able to do. And then finally, it's all about the data. Danny talked a lot about the IoT data, and to me, that's just another source of data. Some other input. But there's so much data today, and every item that's getting connected, these Internet of Things, it's sending more readings to the cloud for us to do analysis. So that's why today AI is ripe for the industry. So at Microsoft, we're talking about the AI transformation, and there are 3 areas that we're really helping customers focus on. So the first area is with the digital agents, intelligent agents, you might call it that. These are really the chat bots. So you think of when you go on a website, rather than trying to navigate around, the bot could come right up and start asking you questions and offering you help. Well, we're just seeing a little bit of that now, but it's going to become more and more prevalent. The second is with intelligent apps. So as all the businesses are building out applications, infusing them with some sort of intelligence. If you were to, go on a weather website, it might be using your location and what you're searching on to say, hey, you're going somewhere warm. Do you want to buy sunscreen? Things like that, adding that intelligence. And then finally, it's the business processes. Danny talked a lot about that today, especially with changing the mentality of what you are selling. Rolls-Royce, not just selling the engine anymore, now selling the engine as a service to some extent. You pay by the hour, and we'll maintain it for you. There's value in the data, and these days, the way that our customers are making more money is monetizing their own data. It's estimated that in the next 3 years, 85% of enterprises are going to be using some sort of AI, and this is also a $1.2 trillion of revenue opportunity. Some of it, of course, is new revenue as people are transforming their business models. And then some of it is revenue that's shifting away from areas of the business that are no longer as relevant with the advent of all of this new intelligence. So what I was going to do today was show you a model, a simple model that was built in Azure Machine Learning Studio, which is one of Microsoft's machine learning platforms. Unfortunately, I had the hardware malfunction right before, if you guys saw us scrambling. Danny hypothesized because I'm a Patriots fan and my computer is not working here. So I did screen capture a couple of things, and I'm happy to show you the demo after when it's not connected. Basically, the idea is that we're looking at data that is historical data for different machines. Each observation is a machine, and then we have a lot of information, such as, was there a failure in the last 6 months? Was there unscheduled maintenance in the last 3 months? What was the vibration score, and so on. So I just screen captured, but there was a lot more data inputs. And what we're tying it to is this asset failure score. So we know whether or not the asset failed or not. And so what we want to do is, using that historical data, build a predictive model to say, hey, when these characteristics are happening, the machine is more likely to fail. So whenever you do these types of models, you do a few things. First, you're going to connect to all of your disparate data. Your IoT data is crucial for predicting machine failures. But you could have things like maintenance logs. You could have all sorts of stuff. Then what you need to do is do a lot of data prep, data transformation. This isn't shown here because that's not really the point, but that is where you're going to spend most of your time. And it is, and then you build your model, and then you're still going to have to go back and do more when you don't get the results exactly as you want. Then you can see here that there is an area for split data and train the model. So what's going on here is I took 70% of the data to build my model, and I'm going to test that on 30% that I held out. The idea here is that if I build a model and I get a similar accuracy between the 70% I built it on and the 30% I tested it on, it means that I found the pattern in the data. If the results look vastly different, then I just modeled the noise, and so that wasn't a good model. In this case, we used the two-class decision forest. It's two-class because I was predicting failure or not failure. In Azure Machine Learning Studio, as well as our code-based Azure Machine Learning Workbench, we have a lot of different algorithms to choose from. I know that these days everyone is coding in R and in Python, so you can also integrate with those languages as well. And then what you're going to do is look at the results. And so you can see here, I have the scored labels, and then I also have the scored probabilities. On the top line, we see that it was predicted that the machine would fail, And if you look a little to the left, it did fail. And the scored probability was 1. Now, if you go down a few, you can see that it didn't always get it correct. So there's a case where there was a failure predicted, or there was not a failure predicted, but it actually did fail. So this is the matrix that we have that shows positives and false positives and so on. So you can see that the majority of the time we're correctly predicting that it failed when it did fail, and that it didn't fail when it didn't fail. So those are the biggest numbers, which are good. And there's still some errors. You're never going to get 100% correct. Or most likely you won't. But you could always refine these models. So what do we need to do that? Well, we apply the model somewhere, and then we collect more data, and then we rerun it, and we try different algorithms. So this is the machine learning. You're only going to get as good a results as you have data, and especially if you're not just looking at machine data, if you're looking at customers or people, they change over time. The machine might not as much. You can also add some of the cognitive elements. So some of the things that is a use case that we're seeing a lot right now is computer vision in manufacturing. So taking pictures of the part that's coming off the assembly line and looking to see if there's some sort of defect. But how early can you detect that defect? Could you detect it 10 parts earlier through that predictive model and say, hey, we know that this is going to happen? And things like that. If you have speech recognition, natural language processing, you could have the maintenance person dictating what they're seeing. And then that can be translated into data that could also be used in your model. You could even get so far as have the bot work with the maintenance person, and he or she could say, well, the temperature is hot to the touch. What's going on? Well, the bot could say, hey, well, what is the vibration? Feed me that, and then tell you how to solve the problem. So there's a wealth of possibilities here. One thing, now having seen Danny's presentation about the do's and the don'ts, so I'll just ad-lib this one. Start off with a project. I know it seems daunting a lot of the times, but you need to pick it carefully. Some people pick projects because they have the data, but it's not really meaningful. So again, going back to factory floor, there was one customer that we worked with, not when I was at Microsoft, not that it matters, it's just a problem everywhere, who wanted to try IoT and analytics. And they were trying to figure out if this machine was going to fail. Standard use case sounded good. Well, when it came down to it, it would fail once, like every 3 years. Go down for a half an hour, and didn't really impact anything. So why do you want to spend your time and money on that? By the way, one failure every 3 years is very difficult to model. So you need to pick things that are low-hanging fruit. So it has to be something where there's going to be that return on your investment. And then you might have a project that, wow, if you could solve it, that would save so much money. What happens if you don't even have data in that area? Well, maybe you just start connecting certain parts of the machine and doing it little by little. So there's going to be that trade-off. It's just very important to choose your project wisely when you do these. And so I'm going to just show my marketing slide of what's going on at Microsoft. We have, to the right are the AI tools. That's the area I like to focus on because I like to build the predictive models. The Azure Machine Learning Studio, which you saw, the Azure Machine Learning Workbench, which is going to be your code-based. Then also, we can connect to a lot of the deep learning frameworks that are out there, like TensorFlow, all this open source. We have the AI services, so the conversational services were the bots that I was talking about, trained services like the computer vision. So we have the intelligence in there as well, but you can also create it yourself. So for example, our stuff would say, that's an apple, that's an apple, that's an apple, that's an orange. They're not going to say, this apple looks, slightly old or a couple days old. This would be the type of thing that you would have to be able to train, and you would need the data to train it. And then we have the underlying infrastructure to do all of this. So AI on data, this is our data storage, and then the different areas for computing. I think that one is it. So, thank you.